Welcome to Bill Knows Best. Bad news, Brian Cox couldn't make it. Turns out our 36 subscriber channel doesn't quite bend space-time yet. Good news? You're stuck with me, Bill, as we dive into a black hole. No PhD required. Ready? Let's go.
Black holes? One of the strangest things in existence.
A mathematical enigma.
You come face to face with the structure of space and time.
Now let me leave, man.
Black holes aren't like celebrities who become famous overnight. They're the result of a highly dramatic event in space. Black holes are born from the death of a gigantic star. Not just any star, though. It has to be a very, very, very large star, at least 20 times the size of our sun. These stars, like hungry eaters, consume their nuclear fuel to resist their own gravitational force and avoid collapsing. But eventually, their fuel runs out. When the fuel is gone, there's no force left to control the star's immense gravity. The star begins to collapse inward, contracting intensely. This contraction is so rapid and energetic that a tremendous explosion called a supernova occurs. It's like inflating a balloon, inflating it, and then it suddenly... Sorry. After that explosion, if the star's core is massive enough, it doesn't stop. It starts to compress itself into an incredibly tiny space. Compressing. And the result is a black hole. It's like fitting the entire weight of the Empire State Building into a pea. Crazy, right? But how is such compression possible? The answer lies within the structure of atoms. Imagine your crush. She's made of billions of cells. Each cell is made of molecules, and each molecule is made of atoms. And atoms themselves are made of protons, neutrons, and electrons, and protons and neutrons are made of... Well, let's not get into that. This is exactly why many people dislike physics. You never reach an end. Everything tiny you find is made of something even tinier. Anyway, 99% of an atom's space is empty. It's like opening a bag of chips and finding its 99% empty space with a few chips. When we say a black hole is incredibly heavy, we mean its density is sky high. All the mass of the original star is concentrated in a tiny point. How much do you think this cute little thing weighs? 1 kilogram? 5 kilograms? Maybe 100 kilograms? But if it were a black hole of the same size, each spoonful of it would weigh 10 billion tons. And that's what makes a black hole's gravitational pull infinite. So strong that if you want to escape it, you'd need to travel faster than the speed of light. And well, you know nothing is faster than light. Not even that fast food you call fast. So practically, if you get caught in its gravitational grip, you won't escape. John Michel, Carl Schwarzschild, boring math and physics formulas. Years of looking at the sky and the collaboration of the Event Horizon Telescope in 2019 finally gave us the first picture of a black hole to like on the internet. How many of these black holes do you think there are in the universe if I say 10? 100? No. Scientists estimate there could be up to 40 quintillion of them in the observable universe. Like sardines in a can. And almost at the center of every galaxy, including our own Milky Way, there's a supermassive black hole sitting and controlling the rest. Each black hole has its own unique characteristics. One of the smallest black holes ever found is J1650. It's only about the size of Manhattan but has 3.8 times the mass of our sun. A step up is the M15 black hole, about twice the Earth's diameter with 4,000 times the mass of the sun. The black hole in galaxy M87 weighs 5.4 billion suns. You could fit our solar system about 4 times across its width. This was the first black hole we photographed in 2019, and one of the largest black holes ever discovered is Ton 618. It weighs 66 billion times our sun and could fit approximately 40 of our solar systems across its width. But it might not be the largest. Phoenix A appears to have a mass equivalent to 100 billion suns. There are still some who think Big Show is really big. The closest black hole we've ever discovered is Gaia BH1. It's about 1,560 light-years away from Earth. That means even if you travel at the speed of light, it would take 1,560 years to reach it. So rest assured, for now, you should be more afraid of the fungi from The Last of Us than black holes. A black hole has different parts, each with its own story. Accretion Disk. This is the glowing, beautiful ring you see around black holes. It's like a giant space donut. This disk is made of gas, dust, and anything else being pulled into the black hole's gravity. As these materials orbit the black hole, They collide at incredible speeds, and due to extreme friction and pressure, they heat up to 10 million degrees, radiating light like a giant lamp. That's why we can find black holes, even though they don't emit light themselves by the light from these disks. Why does the accretion disk look this way? If you want a short answer, it's the interplay of light and gravity. A black hole's gravity is so strong that it even bends light. This accretion disk I mentioned is actually a ring orbiting the black hole, like a glowing space donut. Now the point is that we see this glowing donut from different angles. If you look at it from above, you see the complete disk. But if you look at it from the edge, it's a different story. The black hole's gravity is so amazing and powerful that it bends light even from behind the black hole and pulls it towards your eyes. That's why the cool light strip you see in the movie Interstellar is actually the light from the accretion disk that's both in front of the black hole and bent from behind it, making it look like the disk is emitting light from its side. This means the black hole distorts light around it in strange ways, like your grandparents' eyeglasses. Event horizon. This boundary line is a point of no return. Inside it, space-time is so warped that all possible paths, forward, backward, left, right, all bend towards the black hole's center. It's like sliding down a slippery slope. No matter how much you struggle, you'll end up at the bottom of the valley. This means if you light a sparkler inside the event horizon, its light will stay there and never reach the eyes of those outside the black hole. And now, the dark heart of the matter. Singularity. The singularity is the point at the center of a black hole where all the mass of the initial star is concentrated. Here, density and gravity become infinite. But the interesting thing is that, according to Einstein's theory, the singularity isn't just a place, it's a moment in time. This means for anything that enters a black hole, the singularity acts like a mandatory future. Like tomorrow is mandatory for everyone, no matter how bad it is, it eventually arrives. All right, we've reached the exciting part. If you or anything from an astronaut to a sandwich enters a black hole, first of all, gravity starts pulling you. But not just a simple pull. Gravity differs greatly in different parts of a black hole. Gravity in parts closer to the singularity, like your feet, becomes much stronger than in farther parts, like your head. This difference in gravitational force causes your body to stretch out, like dough being pulled from both sides. This is called spaghettification. Yes, you'll be spaghettified, but not in the delicious sense. This stretching continues and gets worse. First, cells separate, then molecules, then atoms. And finally, even smaller particles within atoms like protons and quarks are torn apart. This means you'll turn into a long string of your constituent particles, moving at insane speeds towards the singularity. In the heart of the black hole, at the singularity, all these particles are compressed together and become one with the end of time. So, practically, you no longer have a physical existence, at least not in the form you currently know. Did your brain freeze? That's normal. At least now you know the best way to clear your chat history with your girlfriend, or those photos you don't like and where to send them. Sometimes we hear that scientists in labs like CERN are smashing particles together at insane speeds and might create a tiny black hole. Well, the truth is, theoretically, it's possible to compress particles enough to create a microscopic black hole. But don't worry, it's not going to swallow the Earth. If a small black hole is created, it's so tiny and unstable that it immediately evaporates and disappears due to Hawking radiation, like a soap bubble that quickly pops. So rest assured, we won't leave Earth in the hands of some excited scientists who want to play with the world. Black holes are strange, terrifying, and at the same time, amazing entities that still hold many secrets. Now you can go and brag to your friends that you learned all about black holes from a real scientist so they can subscribe to Bill's channel too. Until the next discoveries, ciao. Oh my God, you subscribed? This is the greatest moment in the history of YouTube.